children and grandchildren will be inheriting. So thank you very much. I understand that there's quite a lot of experience in the room based on who's dialing in. So we'll be talking about the Shore Standard for Sustainable and Resilient Infrastructure for the next 1.5 hours. We'll be covering a lot of different topics. We've got quite a packed time, but I understand there's also a lot of experience in those different topics that we'll be covering. So I'd really invite people from the, participants to really chime in and bring your experience to the table as well as we go through. So let me share my screen. Hopefully I can get this right. Just bear with me. Mona, can you just confirm that the screen is sharing?
Yes, it is.
Perfect. And do you see the correct screen?
Yes, I do.
Great.
And we all do, I hope so.
Fantastic. Okay, so what's on the menu? 5 points, a quick introduction to say why we're here. Secondly, an overview of the standards. So how do we define sustainability and resilience in infrastructure? A really difficult question. Then using the Shore Standard. So how does the certification work? Looking at then some case studies. So some examples of resilience in practice and what can we learn from that? And then finally, some key takeaways, both from our side, from GIB's side, what we've learned over the past 14 years, and then also as a group, how can we use the momentum that we have currently to accelerate resilience in infrastructure? First up, I'd just like to check that the polling function is working. So if we could go to the first poll, just to understand the people in the room, which risk will your home be most exposed to in the next 50 years? So you should see a poll window appearing on your screen, and you can click one of the examples. It's a relatively short list of risks just to get a flavour of what kind of risks the people in the room are facing. Okay, maybe we can check now if the results have come through. Great, okay. So we have some exposure to earthquake, to extreme heat, 45%, 44% of the respondents, cyclone, flood, sea level rise, one person. Great. Well, not so great, but that's why we're here. That's why we're talking about sustainable and resilient infrastructure. So annually, we're missing about $4.5 trillion worth of infrastructure to keep societies healthy, safe, and on a sustainable development trajectory. This is a huge challenge. Just about us and me. So the Global Infrastructure Basel Foundation, we're a Swiss-based non-profit foundation based in Basel in Switzerland. Our mission is to inspire the world's transition to sustainable and resilient infrastructure. As Mona said, I have a background as an engineer, and I've been heading up the Gib Foundation for the past couple of years. The foundation has been around for more than 10 years. We've done a bunch of stuff focusing on training, capacity building, working with practitioners in the field to understand, what is sustainable infrastructure and how can we understand how to progress it and accelerate our transition to sustainable infrastructure. We've assessed about 175 infrastructure projects globally across 47 countries to a combined capex of There's probably a little more than 52 billion at the moment. And we play an important role in a range of different strategic advisory boards to try and shape the agenda towards a more sustainable and resilient one. What we're talking about today then is the SURE standard. So the SURE standard is a framework in the form of a global voluntary standard to define what sustainability and resilience is for infrastructure. I might just quickly cut to a short explainer video. This will work.
Infrastructure shapes our lives in profound ways. It is the gateway to social and environmental development, to a better quality of life, to a safer, more sustainable and resilient future. Meet Samira and Ismail. These two engineers are currently designing an infrastructure project. It will deliver important services to local communities. The engineers know that building infrastructure is complex. It involves managing trade-offs, stakeholder interests, and delivering good value for money. In addition, the project needs to navigate environmental and social priorities like climate change, resource scarcity, biodiversity loss, and gender, adapt to new situations, and provide restorative benefits to the natural environment in vulnerable communities. To help navigate this complex space, Samira and Ismail decide to design their project using SURE, the standard for sustainable and resilient infrastructure. Samira and Ismail meet Daria from Global Infrastructure Basel Foundation, who helps them understand the SURE standard and how to prepare their project to be certified as sustainable and resilient. The engineers encounter the SURE criteria and how they can align their project with internationally recognized frameworks and conventions for sustainability. For example, the Sustainable Development Goals. Applying SURE to their project, they identify design improvements that benefit nature, that protect their assets from climate change, and that deliver greater social benefits. They also become more aware of the role of their project in broader infrastructure systems and how to influence them to become more sustainable. After meeting the criteria of the standard, Samira and Ismail are successful in getting their project officially certified by an independent auditor. They use their certification when seeking approvals for their project, and investors are excited to be involved in a truly sustainable project that has been de-risked and is well prepared for efficient due diligence. As this project becomes a reality, Samira and Ismail enjoy the benefits of being more sustainable and resilient. This in turn improves the economic and financial sustainability of their project. No matter what kind of infrastructure you are planning, building, or financing, contact us to find out how SURE and the Global Infrastructure Basel Foundation can help make your projects more sustainable and resilient. Want to know more? Get in touch today.
Great. So that gives us a little bit of an overview of what the
What if you could create the tools you need for work yourself?
Great. So that gives us a bit of an overview of what the standard is about, what it's aiming to achieve. What I wanted to do before we delve into the details is just put up some key questions that we'll come back to again at the end. So just four key questions. First one, how can we balance the cost of assurance, balance the cost of applying the standard with assurance that the standard is appropriately applied? So that's a really key question to any standard or label. Secondly, how do we apply a single standard across multiple infrastructure sectors when each sector obviously has a completely different set of characteristics and sustainability challenges and objectives? Thirdly, what sustainability and resilience trade-offs exist and how can they be managed? And then fourthly, how is our understanding of sustainability and resilience changing through time? So I'd like to just keep those in the back of our mind. We'll come back to them at the end, and I'm really very interested to understand your perspectives on these key questions. All right, so let's jump into it. So an overview of the SURE standard. I just wanted to start with this. Larry Fink, the CEO of BlackRock, said at the beginning of 2020, our investment conviction is that sustainability integrated portfolios can provide better risk-adjusted returns to investors. So this is really, really important to understand what's the purpose of getting certified and what's the purpose of us pursuing a certification scheme. And ultimately, for the Gib Foundation, we want to attract better finance to better projects, to have more better projects implemented and enable more sustainable and resilient pathways to come through that infrastructure. So the SURE standard is about demonstrating credibility and transparency to stakeholders. It's about assessing the sustainability performance of infrastructure against international criteria. It's about identifying areas for improvement to improve infrastructure projects, therefore attracting additional finance, mitigating ESG related risks, and that resilience is a key part of that. And in a lot of cases, enhancing project revenue and also the predictability of that revenue. So that's another really key element for financiers when assessing which infrastructure projects to engage with, and also to increase international exposure, which is important for a lot of project developers. Delving into some of those in a little bit more detail. So what are we talking about when we say improving quality and reducing risk? So 3 key points here is it's about ensuring alignment with international best practices and technology, avoiding lock-in to unsustainable development pathways, and anticipating future requirements. So 44% of people in the first poll said that heat waves would be a key resilience risk to your home in the future. So this image here demonstrates quite palpably what a heat wave can do to a piece of transport infrastructure when it hasn't been designed to future heat tolerances. So this is what we're trying to avoid. So that's about improving quality and reducing risk. On the other side, attracting finance and therefore enabling more infrastructure to be built. It's about unlocking green finance and development finance, leveraging conventional finance as well through the better risk-adjusted returns. And ultimately, from a strategic perspective, we really want to establish the unique characteristics of sustainable and resilient infrastructure as an asset class that investors can recognize really the benefits of having reduced risk and potentially improved revenues over a long period of time with greater uncertainty as time moves on. And yeah, we talk about the 7 R's, lowering risk, improving reputation, fostering resilience, increasing resource efficiency, anticipating regulation, supporting recruitment, and increasing revenues, especially from growth markets. So which kind of projects are eligible for certification? The SURE standard set up really for almost any kind of infrastructure. So we don't have any blacklist of projects or sectors that can't apply for the standard, but we know that there are certain kinds of projects that will never get certified. So coal-fired power plants, for example, would never meet the required criteria for climate change mitigation, as an example. Moving on, what topics are covered in the SURE standard? So they're broken down into 3 dimensions: environment, society, and governance, 14 themes, over which there are 61 criteria with 2 overarching criteria, one being the materiality assessment, and the second being ongoing reporting. So on an annual basis, projects certified to the standard need to report back to their commitments that they made whilst getting certified. So in the survey that was sent out yesterday, we asked which are the most important of these criteria to you. And these are the results. I'll get the live results up because I think they're still coming in as we speak. So we can see that most participants said theme G2, which is sustainability and resilience management, is most important. Then we also have climate, so E1, so 58%. Then the next highest is biodiversity and ecosystems. And then the next highest is community protection. So that's really interesting. So the two highest ones here, sustainability and resilience and climate, we'll delve into that in the next section, as well as the biodiversity systems. Okay, interesting that of the people attending today, these appear not to be perceived as important or as relevant as the others. So human rights, labour rights, and working conditions. Okay. Could also be interesting just to have a look at, so I just read through these this morning as they've been coming in, and they seem to match more or less what people have said here, you know, which criteria within those themes. So sustainability and resilience management, biodiversity and ecosystems, customer focus and community involvement. That's really, really key in almost all contexts in which we have worked. Yeah. So more G2, G3, E1, climate change adaptation. Okay, this is a really important point. Thanks for writing that, whoever provided this. For every $4, sorry, for every dollar invested, $4 is saved through climate resilient infrastructure. So that's a really powerful figure as well. All right, so thank you for providing those answers. Oh, I also just wanted to flash on the screen who's in the room. So this is really interesting. About so 30% of the people in the room are from academia, 11% working in social infrastructure, some water waste, energy, but it's apart from that, I mean, most people here are really spread across different sectors. So that helps us to focus our attention a little bit on, at least I guess, on water and energy. But actually, I mean, people are from all different sectors. So let's see how we go as we proceed. Anyway. All right, so those are the topics covered in SURE. They're actually, all of those topics and all the contents in SURE are coming from international frameworks and conventions. And this is some of them, some of the conventions that apply at a national level typically, and often are not that well reflected in at the infrastructure project level. So we encounter a lot of infrastructure projects that are being designed according to regional master plans or you know, municipal master plans, but a lot of the requirements, for example, of the you know, Paris Agreement or the SDGs that are focusing on the national level aren't always being translated to that project level. So that's really the purpose of the SURE standard, is to do that. So the Gib Foundation didn't create the standard. We just convened the process in which we got more than 60 organisations internationally, comprising experts across social, environmental, and governance fields, as well as infrastructure finance, to define, you know, how do we translate these international frameworks and conventions down to the project level. So that's been a really interesting process, and it's not a finished process either. We're continually updating and upgrading and iterating the standard up into new versions. There's two types of criteria: management criteria, which are typically focused on commitments and processes So, for example, using, what kind of management systems do you have in place, or what kind of processes do you have in place, or policies. And then there's performance criteria, which are more quantitative. So measuring, for example, the amount of water being used, or the amount of greenhouse gas being emitted by an infrastructure project. And then cutting across both of them, there's a set of safeguarding red criteria. So these are criteria that can't be opted out of, that any project seeking certification under the standard needs to comply with those red criteria. So those are the three types of criteria. Dipping into the performance criteria, these are, each performance criteria has 3 levels of performance, which is becoming sort of progressively more sustainable, and typically progressively more difficult to achieve as well. So up the end of the performance level 3, we can see it's demonstrating significant positive impact to society and the environment. It's typically going above and beyond the scope of the infrastructure. And level 1 is really just the baseline. So it demonstrates it's thoroughly identified and mitigated ESG risks, and it performs above industry norms typically. We mentioned the materiality assessment. So this is a really important part of the standard. We mentioned earlier, this key question of how do you apply a standard across different sectors and different contexts. So the way that the SURE standard does this is for each criteria to assess first what's its materiality to the project and the context of the project. So looking at impact and importance. And just as an example, a water recycling plant, it could be exactly the same project. If it's built in Western Europe, where currently water stress is much less of a problem than somewhere like the Sahel region, then you might say the importance in the Sahel region is high, but the importance in Western Europe might be medium or low, depending on where it is. And the impact of the project upon that topic would be the same, because it's the same project. So let's say that's high, or let's say that's medium. Then you'd have a highly material criterion for the same project located in the Sahel region, and a medium material rating for a project located in Western Europe. So that's good. The safeguarding red criteria are these ones on the screen here. So you can see there's this came out of a multi-stakeholder process, just defining, which are the no-goes in terms of infrastructure. What do we really need to be safeguarding? So in the environmental dimension, we've got climate change mitigation, adaptation, biodiversity management and conservation, responsible sourcing of water, water efficiency, resource efficiency, air and soil pollution, water pollution. Then in the society dimension, we've got these 7 criteria, and then 5 in the governance criteria. MC is talking about, or is referring to management criteria, and PC is referring to performance criteria. So let's dive now into the environment section. These are all of the criteria within the themes of the environment section. So for climate, we have climate change mitigation and adaptation, and we'll look at them in some more detail. There's 3 criteria under biodiversity and ecosystems. Environmental protection then has 5 different criteria, looking at a few looking at water, then also looking at materials, looking at resource efficiency, so how do we use those materials, and then how do we manage the waste coming out of it. Then natural resources, looking at air, soil pollution, water pollution, pest management, specifically what kind of chemicals are we using to control pests, then noise, light, vibration and heat and cumulative impacts. And then lastly, we've got landscape and land use. So where's the project located? what's its design in relation to landscape, how much land is being used, is it grey field or green field, was it agricultural or not, and then how are we restoring the soil that we're displacing whilst we're implementing the project. So that's about maintaining precious topsoil as topsoil and not mixing it together with other subsurface kinds of soil. So these are the criteria in the environment section. We had three criteria that through the poll people said were of most interest or importance. So let's just have a deeper look then at climate change adaptation. So the actual criterion is a little more detailed than this, but this is just a summary. So the project shall avoid, or if not feasible, reduce project-related greenhouse gas emissions. So, for example, through the adoption of renewable energy sources, energy efficiency improvement, reduction of fugitive emissions, reduction of embodied energy, afforestation, and reduction in deforestation, or other changes to the project siting, which could reduce greenhouse gas emissions required for the same service delivery. And there's 3 performance levels. So the first performance level looks at scope 1 and 2 greenhouse gas emission and requires that they're lower than what the project would need to emit to be in line with the nationally determined contribution to the Paris Agreement. Then performance level 2 is to have net zero for scope 1 and 2. And then performance level 3 is net zero for scope 1, 2, and 3, and reduced embodied carbon. So that's the climate change adaptation one. And since this is a red criterion, all projects would need to have at least need to be aligned with the nationally determined contribution to the Paris Agreement. Next one then, climate change adaptation. So the project shall demonstrate its ability to withstand identified climate change risks and hazards in plausible scenarios throughout the project's life, and conduct an assessment the project can withstand future climate change conditions identified by the IPCC. So this is a simplification of the actual criterion in the standard, but it's more or less saying performance level 1 is that the project's designed for RCP 4.5, meaning an average rise of about 1.8 degrees Celsius. Performance level 2 is, in addition to that the design of the infrastructure is using location-specific interpretation of climate data and periodic reviews, and also has a business continuity plan with a reserve budget for that plan. But ultimately, it's still designed for RCP 4.5. And then performance level 3 is designed in addition to RCP 6.0, so an average rise of 2.2 degrees Celsius. So this is a really important criterion, and one that is also being continually reviewed and revised as the new reports come out. Okay, then criterion E 2.2, biodiversity and ecosystem conservation. The project shall protect natural capital, critical habitats, ecosystems and species as recognised by the IUCN Red List. So wherever possible, the standard also recognises or references other frameworks, like the IUCN Red List is one of them. Identify endangered species, define biodiversity values, conduct a flora and fauna assessment. You'd think that's basic and is done for most projects, but it's not always the case. So that's certainly in there. And then You can use accepted methodologies to achieve the same outcome. So this is one example of a methodology that the Shore Standard requires projects to use, and it's called BBUP, so the Business and Biodiversity Offsets Program. But wherever possible, the standard tries to recognise other things to avoid projects doing rework or doing the same study twice under two different names. And then again, the three performance levels, just to sort of summarize, is that we have no negative impact and good international industry practice for endangered species and critically endangered species, and for protected areas category 1A and 1B. And then performance level 2 is stepping that up from no negative impact to no net loss and no negative impact on the next level up of species and also habitat. And then performance level 3 is complete avoidance of negative impacts on biodiversity, habitat and ecosystems, in addition to a net positive impact and no negative impact, no impact on species except for the lowest level, and no impact on protected areas. So a huge range of the different protected areas. That's more or less how it works for biodiversity and conservation. Let's go to another poll. So in your region, how successful is regulation in ensuring infrastructure is climate resilient? So this is an ongoing question for us. What's the role of a voluntary standard? We'd think that it needs to, that it's helping on the one hand to level the playing field across different regulatory environments to see that we're speaking the same language, but also to try and push to push that level, or push that benchmark up, to see that that regulation's actually coming along with science and becoming more and more appropriate in terms of making projects more resilient. So let's see the answers, what everyone thinks about how regulation's going in their region. Okay, so very few people think that it's fully unsuccessful. About a third of people think it's somewhat successful, a third think it's unsuccessful, and a third think it's successful in some sectors, but not in other sectors. So I think that more or less reflects GIB's experience as well. Very, very case dependent from what we see in the infrastructure projects that we assess, not only on the sector, but also on the criteria. All right, let's move on to the society dimension. So we've got 5 different themes here: human rights, labour rights and working conditions, customer focus and inclusiveness, community impacts and socio-economic development. So here we've got 3 different criteria looking at human rights, and we have one specific one looking at security personnel. Because around infrastructure projects, this is a key area where infringements of human rights occur, particularly for vulnerable communities. And labour rights and working conditions, we've got 9 different criteria. So spanning policy, rights to collective bargaining, discrimination, forced labour and child labour as well, which we also notice is surprisingly important, especially in the construction phase of infrastructure projects, but also then in the operation of them, depending on the sector. And certainly in the agricultural sector, that's one that we spend a lot of time working with stakeholders on. Then occupational health and safety, grievance mechanisms, working hours and leave, fair wage, retrenchment. So a lot of these really reflect the ILO conventions for labour rights. Then customer focus and inclusiveness. So this is one that in the responses to the poll yesterday, a lot of people also saw this as an important theme. So minorities and Indigenous people resettlement is obviously one of the key red flags that we see when we're assessing an infrastructure project. Then cultural heritage, which actually is another important red flag, not from a resilience perspective so much, but from a when we're working with infrastructure financiers, this can really blow out the time and the time and the budget of an infrastructure project. So this is one that they also pay a lot of attention to. And decommissioning and legacy, what's left beyond the life cycle of the project. Management of public health and safety risks. Then moving on to community impact. So how does the project impact upon the community? We've got physical accessibility, provision of basic infrastructure services, user affordability. So this is about avoiding the situation that new infrastructure is only servicing a privileged minority, for example. Delivery of public health and safety benefits. And then finally, socioeconomic development. So direct employment and training. So how are we making sure that the project is sustainable and resilient in the sense of moving the capacity locally rather than just shipping in capacity, foreign capacity, which then leaves again. Then S 5.2, indirect and direct economic development enabled by the project. So what's the project's role in the broader economy? And then finally, gender equality and women empowerment. So just one example then on gender equality and women's empowerment. The overall requirement is to mainstream gender equality into the project, respect the Convention on the Elimination of All Forms of Discrimination Against Women, do an analysis on gender equality, implement a gender action plan, and that gender action plan should include some minimum points in it. These are just some of them, it's a summary. So a mechanism to ensure fair representation of women in the project team, to design infrastructure to eradicate negative effects on women and other sensitive groups, identify opportunities for empowering women, implement gender sensitive facilities, which could mean, lighting, safety, sanitation, provide gender training to all staff, and then to have a zero tolerance policy to sexual and other types of harassment, discrimination, violence, and or abuse of men or women, LGBTQ individuals. And then some of the ways of how to implement that. So it's, first step, a gender equality analysis and a gender action plan coming out of that. Make sure that all the data is sex disaggregated. Make sure that project documents are gender sensitive. So this includes things like language. So making sure that we're using inclusive language, especially around recruitment. That's very, very critical. And then to see that the project provides evidence of efforts to reach women for job vacancies, opportunities for engagement, involvement and training, and that includes in stakeholder engagement processes. Okay, then looking at the third dimension, governance. So we've got four themes: management and oversight. So this is looking at how is the project set up? Is it being implemented with the right structures in place? Risk management there is a really key criteria. Oops. As is infrastructure interconnectivity and integration. So we see a lot of projects that unfortunately haven't been well integrated within the broader infrastructure system, meaning that sometimes the use of that infrastructure can be a lot less than anticipated. or services can be duplicated, or yeah, or different different potential benefits, or ways in which the infrastructure could leverage the other infrastructure around it are not being utilized. In resilience, so sustainability and resilience management. So then specifically, how do we manage sustainability and resilience within the project? So looking at what's the environmental and social management system that's in place, and what are the requirements within that? Are we taking a life cycle approach to the project? How are we planning for resilience? Not only technically, but also financially. What kind of insurance do we have in place, for example? Then what emergency response preparedness do we have in place? How do our supply chains get affected by disaster, or how resilient are our supply chains? And then what pre-existing liabilities exist? Then the last two themes here is stakeholder engagement. So how are we engaging with the communities around the project? And then anti-corruption and transparency, which is an important topic across all regions that we've been working. So just very quickly then, two example criteria on resilience planning. So some of the requirements of this are to do a vulnerability assessment, a risk assessment, short and long-term adaptive measures, to continually update the adaptation measures based on learnings and changing environment. That includes changing science through time, and then to have suitable insurance in place. Then another example criterion is engagement and participation. So this is looking at having ICP, so informed consultation and participation, to avoid designating issues as non-negotiable, and to have consultation lead to actual decision-making based on that consultation, to make sure that consultation is inclusive, fair and representative, and documented and reported to senior management. So a lot of this is coming from the IFC performance standards, but then also looking at realistically, where do projects fall down historically in terms of engagement and participation, and how can we learn from that and ensure that it doesn't happen. All right, so let me pause there briefly and just see if there are any questions that have come up so far on the standard before we delve into the certification. So I can see there's a few questions being posted. I'll just quickly. Sorry, go ahead.
Should we take the questions? Do you want to take the questions right
away? I just wondered if anyone had any sort of urgent questions on what we've covered so far. Otherwise, I can keep going with the next section, which is about how do we employ the standard. Maybe I'll just answer one question if that's okay, Mona.
Sure.
Yeah. So this is from an anonymous attendee. Sure, standards seem to be more orientated towards planning and development of new infrastructure projects. Can the standards be implemented by transport infrastructure managers for managing a large portfolio of built assets such as bridges, culverts, rail tracks, etc., and how? Yeah, so that's a really good question. That we'll cover in the next section. That the standard, I think in my experience at least, is most useful during the design phase, because that's where you have the most ability to change the trajectory of a project. But the standard's actually been set up to be applied at any point in an infrastructure project's life cycle. So if you apply the standard at a later point, you'll be looking more at operational improvements or additions to the project to see that they're more sustainable through time, even though the main capital expense has probably already been made. So I'm trying to think in terms of, you know, bridges, culverts, rail tracks, etc. Some of the outcomes of using the standard might be in terms of the way that training is done around, you know, risk scenarios or, you know, disaster scenarios. How do you prepare for emergencies? What kind of equipment do you need in place? How do you coordinate with other surrounding infrastructure assets, you know, or managers of infrastructure? So certainly it's very useful at all stages of the infrastructure project, all the way through to decommissioning. But in my view, I'm always sort of most happy working on an early stage project where you can really get in and, you know, change the fundamental design of the project. Okay, let's leave it there, as you suggested, Mona, and we can come back then for question and answers at the end.
Sure.
So, how does the certification work? Let me share my screen again. So we've got three types of certification, and this comes back to one of those key questions that we put on the screen at the beginning. You know, how do you manage the cost and the assurance? Higher levels of assurance cost a lot more, you know, time and resources to have an auditor actually go out on site and take measurements and check documents and such. It's just not always appropriate. So what we've done is put in place a self-assessment, which is very, very easy, low cost, and basically lets projects assess for themselves, you know, how do we stack up against these criteria. And I think that's really useful for any infrastructure project to do. And almost all projects will walk away with, you know, a small list of, well, a small or large list of things that they haven't thought of, or that, you know, that they should be integrating into their design of their operation. Then there's an appraisal, so where you get a sustainability expert from our foundation to work you through a series of workshops where you go through the different criteria, you look at how they apply to the project, and you come up with a set of actions, and then also a communication of where the project is sitting in terms of its sustainability. And then there's a full certification, which is done by accredited certification bodies. So TÜV Nord or SGS, or there's another Swiss one called True and Fair Expert. And that then results in a certificate of either bronze, silver, or gold. So now this is answering the question that just came up. So how does certification at different stages of infrastructure development work? So very broadly speaking, if we say we have planning, design, construction, commissioning, operation, decommissioning, applying the certification earlier means that an auditor or a sustainability professional who's applying the standard will look at what has the project done, what evidence is there, and then what is being committed to in the future, in terms of, you know, what will be built, how will communities be engaged with, how will employees be treated, all of these questions. Similarly, if you apply the standard later, you'll be you'll have a lot more evidence of the things that have already been done, because you've already constructed the project, for example, you've already employed people, you've consulted, you've done your free, prior and informed consent, etc. And you'll have many fewer commitments to anticipated actions. So from an auditing perspective, it's much easier to apply it later in the piece, but it's more useful, in my opinion, to apply it earlier. What's the full certification process? And it's got 7 steps, starting with registration through an online portal. which also has a built-in self-assessment that we talked about, where you look at both the materiality and then the compliance to the different criteria. You then engage a certification body, and then you put your self-assessment out for public consultation. So during this stage, the public gets to see all of the commitments that you've made and the way that the project developer sees their project in terms of its sustainability. And they have then the opportunity to say, no, you're not considering these, these additional impacts upon my community, or no, we disagree with this or this. So that's a really important step. Then independent third-party audit. So the certification conducts an audit in 2 stages using the ISO standard 17021, which are slightly adapted to the Shore standard requirements in a document called RQ01. And that includes a desktop assessment and then an on-site audit. Then there's some iteration loops here where the certification may find some non-conformities to which the project needs to identify corrective actions. And those corrective actions are either significant or less significant, and they should have a time-bound period in which they need to be implemented. Then there's a final report, and then there's a decision on whether the certificate should be granted or not. And if it is, then it'll be either bronze, silver, or gold certified, which lasts for 5 years. And there's a yearly surveillance in which the project needs to report against some KPIs. So, for example, greenhouse gas emissions, how much water is being used, some gender KPIs. There's a whole range of things that the project will report. So that's more or less how the certification process works. Then so the self-assessment and the appraisal have similar processes that are a little bit simplified. Well, the self-assessment is basically an online checklist, and the appraisal is a set of workshops, and it's less of an external audit, and it's more of an inclusive process in which we really try to identify project improvements. Okay, which takes us through to the case studies. I hope we're doing okay. We're a little bit behind time, so I might try and speed it up a little bit. We've got just three case studies of 3 very different infrastructure projects. This is sort of a snapshot of some of the projects that I thought could be interesting to talk about, but we only have 9 minutes. Sorry, we only have 90 minutes today. So we'll talk about a regional railway project in India. So this is a project, I think it was in Gujarat province. I won't name the specific project, but basically the components of the project were an expansion of additional rail lines, an enlarged freight handling platform, and construction of a new station infrastructure. So this was basically a platform that was about 700 meters long and 33 meters wide. So quite a significant platform. The tracks were about 6 meters above sea level, and the capacity of the facility was about 25 million tons per year of freight traffic running between a port. So this was located about, I think, 5 kilometers from the ocean or so. So this was quite a close connection to the port, and then running inland from there. So that's the basic characteristics of the project. So in a very brief snapshot. I just want to, so based on that, based on very limited information, we've said it's close to the sea. Those are the components of the project. That's the purpose of it. So it's primarily a freight handling facility, but it also runs passenger trains. Just want to put another poll up. Which considerations, in your opinion, do you think are likely to be the most material to this project based on that very brief snapshot? So we've got sea level rise, extreme heat, flood, drought, or none of those. Just leave a couple of minutes to gather some answers. Okay, maybe that's enough. Let's see what everyone thinks. Okay, so most people said extreme heat. Then next biggest was flood. Then next was sea level rise, drought, and one person thought none of the above. So let's have a look at how the project scored. So this is a bit of a snapshot that we do to say, you know, against these different elements, how is the project looking in terms of its current performance in dark blue, and then light blue is its future performance. So looking at those four different options, so sea level rise for the next 100 years at that location for RCP 4.5 is looking at about 1 meter, and the elevation of the tracks was about 6 meters. So actually sea level rise wasn't a problem for that particular project. However, the project's main purpose was to transport freight to the coast, and most of the factories and the industry that it was servicing was going to be severely impacted by sea level rise. So for that reason, whilst the infrastructure itself wasn't being impacted, its supply chain really was. So for that reason, it was very, very high materiality. Extreme heat that people said was the most important. The assessment also showed exactly that as well, that extreme heat in that region was going to be increasingly a problem for the ongoing maintenance and operation of the assets. So the project developer was doing a really good job at looking at you know, how can they mitigate that? How can they also build it appropriately into their business models to say, you know, in the future, a certain number of weeks or days, the project would be, the infrastructure would not actually be able to run when it's above a certain threshold of temperature. Drought was an issue for the region, but not specifically for this infrastructure project. Again, it was more of a supply chain issue that a lot of the factories, the industry that this rail infrastructure was servicing were relying on a limited number of water sources that they themselves were decreasing for various reasons, mostly climate related. And that the contingency plan or the future planning for water supply to the area was typically relying on water resources outside of the area that were also being relied upon by other regions. And there wasn't really a very good coordination from one region to the other to say, in the future, we're both going to be relying additionally upon this, you know, reservoir or this water resource. So that was very, very interesting. then yeah, so just to look at that, here's that image again of where it can go wrong for rail in extreme heat. This is just one of the expansion joints on site. So they were putting a lot of effort into doing their calculations to see, how many of these joints and what capacity is needed. Same with the overhead electricity lines. And obviously, I know we didn't talk about that, but the flooding in the area was also a really severe problem, and the project was taking this into account by putting a bit of additional capex into seeing that the rails were appropriately raised for flood events, but also, and this is something that they did after the shore assessment. With this 700 meter times 30 meter new platform that they were building, they actually saw that with this new impermeable surface, they're increasing the flash flooding risk for downstream areas. So they put in a really interesting water recycling system there where they could capture the water running off that, and then they could use that for some of the factories that were located nearby. So that was, a good example of how they could make an improvement at pretty minimal cost. Going to the next case study, totally different one. This is a major European airport master plan through to 2030. I'm not naming the specific projects, but this particular master plan had a capex of about 2 billion euros over that time, that was comprising 70 different work packages, including a new passenger terminal, new baggage handling system, optimization of the airplane stands, and some other capacity expansion. So a lot of buildings going in, a lot of machinery as well, changes in the energy usage through time, and all under a lot of uncertainty. So let's go to the next poll. So which considerations are most likely to be material to this project, in your opinion? So I've got a couple of examples here: increased precipitation, increased temperature, including heat wave duration and intensity, flooding, changes in wind speed and direction, more frequent and more intense convective weather. Just leave that a couple of moments once we see what everyone thinks. All right, let's have a look. Okay, looks like a pretty equal spread across these points, which is good, because all of these elements in this particular project were really serious. And I think, looking at the recent flood events that we've had as well, I think people are now realizing that Western Europe as well is particularly vulnerable to flooding in a lot of locations, and airports especially. So increased precipitation was really interesting from an operational perspective, because in certain events the airport wouldn't be able to operate as usual due to if precipitation was particularly bad. And then also looking at the downstream impacts of precipitation. So to what extent does the infrastructure contribute to flash flooding downstream? How can we put in place water collection systems for example, from the runways that would enable either reuse of that water or just increase the retention capacity to see that that flood risk isn't eventuating. Then increased temperatures, including heat wave duration and intensity. So this particular airport historically was much more used to cold weather than it was to hot weather, and that was reflected also in all of the equipment specifications. So then looking at, for the tender requirements of the future equipment, to see that we can either push up the operating range for ambient temperature, or that we can put in place design measures such that the location of the equipment would be protected from the worst of the heat. So that was very, very material. Flooding we talked about already. Then these last two were very interesting. Changes in wind speed and direction, and more frequent and more intensive convective weather. So these are two anticipated impacts of climate change in this region that was going to have a potentially huge impact, not only on this airport, but also on the diversion airports around it. So with more inclement weather, there would be more occasions in which planned flights wouldn't actually be able to land as intended. And then they would need to go to a diversion airport, which, if it's also suffering the same inclement weather, would then cascade the problem further. So these are some items which were not at all in the master plan before we did this assessment against the standard. But the fact that they were doing this master planning process and integrating the shore standard into it enabled them to really do a lot of great improvements. So, for example, improving their approaches to tendering, building in key climate risks to the project, also looking at key technology risks. They realized that a lot of their revenue is actually coming from parking, and with self-driving cars likely to hit the market within the time frame of this master plan, that business model may need to really seriously change. And the same on the climate change side, looking at the impacts of regulation and customer choices with regard to flying and where fuels are coming from. And this airport was able to do some really interesting stuff in terms of the way that they could incentivize planes to spend less time taxiing, and also to use biofuels where possible. So really interesting. Also improved water management and improved material sourcing for all the new buildings that we're going to put in. All right. Going to a third case study, totally different once again, but back in India. So an eco-industrial park in India. This is one that was along the Delhi-Mumbai industrial corridor. Basically a mixed zone development, including industry, retail, residential, commercial, and all of the associated infrastructure. So electricity, transport, water, wastewater, solid waste, etc. I won't do a poll. I'll just jump straight to the results of what we found. Some elements of leading practice were some really good recycling practices in place, really good safety systems, large impact on the local economy and enabling environment. That was enabling development, and well-developed resilience planning, especially from a flood perspective, which was one of the key issues in the particular area, as well as heat waves and potential drought. Then some key risks, so limited engagement with future users to determine the service requirements. So there's a potential that they'd be putting in insufficient or the wrong kind of infrastructure for the future users, and that decommissioning was not at all part of the project plan. So there was a risk that the kind of infrastructure we're building now might be less adaptive to potential future users, or that we're making material choices that wouldn't be able to be reused or recycled or repurposed. So yeah, after this, the project went and engaged more closely with the industries that would be actually using the site, and put in place both a plan and a budget for decommissioning afterwards. So that was really good. So that was just some highlights. Then, just generally speaking, some highlights from the work that we've done with the projects that we've assessed over the years. I think most projects will walk away with better alignment to the Sustainable Development Goals, better understanding of the climate change impacts upon their projects, better inclusivity of the stakeholders, which then also leads to better social license to operate, biodiversity in a lot of the regions where we work is unfortunately not on the top of either the regulatory agenda or that of the project developers. So that's really good as well, that we see some positive impacts for biodiversity. But also a lot of these things, I think we often approach projects, and at the beginning they have the perception that all of these changes, all of these things we're assessing will lead to cost increases. And it's interesting for us to see that in most cases we're generating significant cost savings through, using less materials, being a little bit smarter about the way that we go about designing and implementing projects. We're also improving tender requirements often to see that the projects are being deployed more smoothly, and all of that is resulting in, better attraction.
We are unable to hear you. Are you there?
Sorry for this. We're just checking if Louis can be back. Yeah, there he is.
Great. Sorry, I don't know what happened. Where did we get up to?
Not sure. Let's go again. Yeah.
Okay. Where I noticed something seemed to drop out was just we were going through these key questions here. So could you hear me going through these points?
Yeah.
Okay. Okay, fantastic. So just circling back to the key questions that we had at the start, how do we balance the cost of the assessments with the assurance that you get out of it? How can you apply a single standard across multiple infrastructure sectors? What sustainability and resilience trade-offs exist and how can they be managed? And how is our understanding of sustainability and resilience changing through time? And how do we embed that into the standard? So those are some of the key questions that I wanted to put on the table. And then also in terms of the knowledge gaps that we perceive in the market, I think that these are some key points. Best practices for improving project resilience, having access to data on the shocks and stresses, particularly related to climate change, and then really locally, so at a subnational level, knowledge of how to move finance to resilient infrastructure. And from our perspective, some key elements that are needed from us as a community to build is really the capacity, so local capacity in these areas, improved regulation, and then incentives to move the whole market in that direction. So let me leave it there. I'll stop my screen share and then we can go to some questions and answers.
Sure, thank you so much, Louis, for this comprehensive presentation. Should we go over the Q&A? I think it's visible to you. Do you want me to take them?
So after my Zoom dropped out, I no longer have access to the chat or the Q&A that was added before I rejoined. So maybe you could moderate that a little bit.
Yeah, I can do that. I can do that for sure. The first question is by Sagar. He asks, is there any standard for hydroelectric infrastructure projects?
There certainly is. I'm not a hydro expert. I'm not sure what the best standards would be there. The shore standard, as I said, applies to all sectors. So we've done several hydro projects, but there's other technical standards, of course, specific to hydro. So sorry, I don't know any off the top of my mind.
Suzanne asks if the countries that require to participate in zero carbon, what is the cost for it and who will pay for the additional costs?
Yeah, I mean that's a really that's a really important question that goes a little bit beyond the scope of the shore standard. I know that's a key question that we're hoping will be answered in the next COP, and where GIB is part of a working group on answering this question of how do we mobilize the pledged finance that should be associated with the Paris Agreement. But unfortunately, it's not an easy one to answer. But I can say this on more of a technical level. A lot of the projects that we work with, there's often an increased capex, but a decreased net present value, significantly decreased net present value associated with reducing the carbon emissions of projects. And the difference between the carbon intensive option and the renewables option is really increasing year by year, whereby we're almost at a point where it just really doesn't make sense to be using diesel, gas and coal any longer. So I mean, I'd be interested to have more of a detailed discussion with some specific examples, of the infrastructure projects that we're talking about, to see, what do those two examples look like. But just anecdotally speaking, a lot of the cases for us, it makes a lot of sense for the project developers to consider photovoltaic or wind or also geothermal.
So there are a few clarification questions which I would request the participants to go through the standard to know what the criteria actually means. The link to the standard has already been shared. There's a question by Mr. Arun Bandhari which says, in social criteria under theme socio-economic development. But Louis, you also have access to all the questions now. Maybe you can also see if you want. What is ISO 14090 standard approach in the socio-economic development infrastructure? Theme is considering about social environment.
Can you repeat which ISO number? 17021.
The ISO 14090, Standard for Climate Adaptation.
Okay. And what
Theme
was
is considering about social empowerment. In India, we developed EIA for infrastructure projects, which provides social impact assessment, reporting, and public hearing for displaced projects. How the present standard provides tools and techniques in socio-economic development, and what it actually measured within the standards.
Yeah, I mean, the way that the standard works is it tries to use whatever nationally required assessments or project development requirements already exist. So in India, that certainly includes the SIA and the EIA requirements. And then in some cases, the standard in its checklist of minimum required inclusions into those studies, in some cases, the regulatory requirements aren't quite enough. And so then we would ask the project to do a little bit extra. And I know in India, there's quite a lot of difference from sector to sector, what's included or not included in the EIAs and the SIAs. And we've had a lot of, most projects in India where we assess them, we'll need to ask them to go and do, for example, additional climate change assessments. But I think the social inclusion elements are fairly well covered, generally speaking. But that's something that we would check on a case-by-case basis. I hope that answers the question.
The next question is around SURE certification, which says that does SURE incorporates cascading and compounding hazards, risk in terms of infrastructure resilience?
I'm sorry, Mona, could you say that once more?
Yeah. So does SURE includes cascading and compounding hazard risk in terms of infrastructure resilience?
Yeah, absolutely. And great question, because it's a really important one. So we look at that in terms of infrastructure connectivity, and then also in terms of cumulative impacts. And that's often one of the really key themes or features that is not adequately covered in the projects when we get to them. Is to look at, what are the other projects that are going on? How are we also coordinating with the other infrastructure managers, and to see that we have a combined emergency response approach, for example, or that we're all prepared, or that we're not all relying on, like in the case study example, not that we're all relying on the same emergency water resource, which will not be sufficient for everyone. So certainly we look at that very closely, specifically through those two criteria, the one on interconnectivity and on interconnectivity and cumulative impact.
So I'll take the next two questions together. So it says, is SURE a new set of standard beyond ISO, or is it part of ISO, BSI, or US, etc.? And what are the certification bodies for this?
Yeah, so the SURE standard is not an ISO standard, but it uses an ISO standard for its assurance. That's ISO 17021, but it's an ICL standard. So ICL is the umbrella organization for sustainability standards. So it's the same family of standards as other voluntary standards like the Fair Trade label or the Marine Stewardship Council label, MSC, or FSC, or the Rainforest Alliance. So it follows all of the requirements and the standard setting procedures and codes of practice of those.
Thanks, Louis. The next question is around choosing the right kind of standard or certification between, for example, LEED and SURE and other similar standards. So are there any tips which people should consider?
Yeah, that is a really fantastic question, because there are a number of different standards, and obviously from our perspective as running the secretariat for the standard, we can see that all of the standards are very different to one another. Certainly LEED and SURE are very different, and SURE is the only sustainability voluntary sustainability standard that's really designed by and for emerging markets. So that's sort of the key differentiator and why it's particularly applicable. But something that we're working very hard on is to see that we have better harmonization between the existing standards. We're cooperating quite intensively with as many different other standard secretariats or organizations as possible. And our mission is really to see that we can get the same kind of harmonization in sustainability standards as what we've had, for example, in accounting standards over the last 50 years or so. So that's a goal for us, and it's not only is it important for project developers to know which standard to use, and it saves them a lot of hassle and bother. It's also important for the financial sector to be using the same metrics across regions and across sectors to evaluate infrastructure projects, so that we can really build the data that's needed to demonstrate the superior financial characteristics of sustainable and resilient infrastructure as an asset class. So that's something that we're really working hard on.
I think this answer is applicable to many participants who've been using these standards. So the next question is around certification, and it says, for the self-assessment certification type, is public consultation stage applicable, or is it mandatory or a choice? And a follow-up to that is, after certification, who monitors KPIs annually, project owner or certification bodies, and does GIB has a role to play?
So the public consultation is mandatory for any project that wants to get certified. Some projects come to us with unique intellectual property or other sensitive circumstances which prohibit them from doing the same public consultation. So in those cases, we say, well, you can't get certified, but we're happy to work with you to do either a self-assessment or an appraisal. So they won't get a certificate. And regardless of whether we do that public consultation or not, our assessments will require that the project does do the right level of public consultation and community involvement and free prior informed consent, etc. But the short answer is any certified project has to do that public consultation.
That's wonderful. So the next, how are we on time? Can we take a few more questions, or should we?
Yeah, I've got another sort of 7 minutes or so, if that's helpful, Mona.
Let's go for another 2-3 questions, and then how about that? Should I take the next question first?
Yeah, please. That would be great.
So the next question is around retrofitting of the existing infrastructure. Do SURE ratings and mappings address the retrofitting of existing infrastructure, and how?
Yeah, so the same way that we can look at the design and planning phase of a project, or the construction or operation phase, we can also look at retrofits or additional phases of an infrastructure project. The important thing for us is just that we define the scope of the project clearly. So for example, if you're operating a coal-fired power station, and then you say, well, within that power station, we have the water treatment system, and we want to get a Shore certificate for the water treatment system, which is actually part of the whole coal-fired power station. If a project came to us and said, well, it's just this one retrofit, that we want to certify, we would say, well, no, we can't actually draw the boundary only around the water system. We have to look at all of the, the broader infrastructure piece to see that it's also sustainable, if that makes sense.
That completely makes sense. And the next question is also around that, so the next question asks, if the project proponents do not have data relevant to the project as it is evolving throughout the project, so can this still be certified? And another question similar is, projects already registered in other ISO standards like GRESB rating, can the KP data and other infrastructure project data be used for Shore standards?
Yeah. So I think GRESB is not an ISO standard, but we collaborate very closely with GRESB, and we have exactly that intention, to see that the data that GRESB is asking for is the same kind of data that we would use to assess an infrastructure project, so that the project doesn't have to do it twice, basically. So wherever possible, we're trying to make it very, very efficient for a project developer to go through this process.
So the other question is from Rupesh Shrestha. It says, it's kind of confusing many times due to different standards or requirements. Banks expect project developers to fulfill these different standards. So how can we make sure that financial markets or banks are using the same standards? I don't know.
I think that relates to the previous question. And there's a number of initiatives that we're supporting at the moment to try and see that we can have that coalescence around a set of agreed indicators. So, some of the initiatives that are going on, there's the Aligned Indicators for Sustainable Infrastructure, AISI, which is an initiative that's been led by GIB in collaboration with GRESB, SQL, BREEAM, ISC in Australia, and Envision in the United States, where we've defined a set of indicators which are threaded throughout all of our individual systems. But the idea is to say, these are the definitive criteria that define sort of the lowest minimum requirements for sustainable infrastructure, or at least, signals, efficient signals of sustainability in infrastructure. So that's one initiative. We're also supporting the Fast Infra initiative, which is led by a group of organizations, including Macquarie and the World Bank, which is about defining a standard which uses other standards like Shore and Envision and ISC to also create this common language. And another one is the Blue Dot Network, which we're also supporting with a similar goal, but a slightly different angle. And then there's a range of others that I won't go through. But that's what we're aiming for, is to have that coalescence. But unfortunately, we're not there at the moment. We're trying to really accelerate that, because we don't have much time, remaining before the impacts of climate change really start accelerating in an exponential way.
The last question is around the same thing, that how is SURE similar, different from other standards, having climate resilient index such as H, and like you just said, that we are developing a language which will eventually need to resonate. So thank you so much, Louis, for this wonderful presentation, and I hope we could take up all the questions by all the participants, and I'm sure many of us had a lot to take away, especially from the case studies that you shared around transportation and in diverse geographic contexts. So, and thank you all for attending this session. The third session of the masterclass will be held on 5th of May during our flagship event, the International Conference on Disaster Resilient Infrastructure, at 11 to 12:30 IST. The conference will bring together policymakers, researchers, and practitioners from across the world to strengthen the global discourse on disaster and climate resilient infrastructure. To attend the third session, we request you to kindly register on the conference link on the website, and the schedule of the conference will be put on the website by the end of this week. And we also invite all the participants in other sessions of the conference running from 4th to 6th of May 2022, set aside the backdrop of global transitions that are transforming the world we live in. The conference will provide an opportunity to address issues around infrastructure transitions, risk governance, and finance, and putting people at the center of building resilient infrastructure. Also, the video link for today's session will be available on the website by tomorrow. We shall also circulate the assignment after today's session. And we really want to thank you, Louis, for taking this session. And it was really amazing to have you. And we thank you, all the participants, for all your active participation. Until the next masterclass session, we say goodbye and have a productive week ahead. Thank you.
Thank you so much, everyone. I've just dropped my email in the chat box as well, so do feel free to reach out to me or the team.